Good day, everyone. In this video, we're going to talk about the concepts of indeterminate forms and L'Hopital's rule. Recall lang natin yung L'Hopital's rule. Let f and g be differentiable functions on an open interval I containing a except possibly at a. And g prime of x is not equal to 0 for all x in I except a. If the limit of f of x over g of x as x approaches a is an indeterminate form of type 0 over 0 or infinity over infinity, then this one is equal to this one, no? So kung mapapansin ninyo, hinanap lang natin yung derivative ng f and ng g. So pwede siya provided that this one exists or is equal to positive or negative infinity. Yung L'Hopital's rule natin with suitable modifications is valid if yung x approaches A natin ay papalitan ng x approaches A from the right or from the left o kaya naman x approaches positive or negative infinity. So ang nabanggit lang natin na indeterminate form na type ay 0 over 0 and infinity over infinity. So paano kung hindi ganyan? So if the limit of f of x times g of x as x approaches a is an indeterminate form of type 0 times infinity, then ita-transform natin yung function na to into this one, no? Kahit alin dyan sa dalawa. So kung mapapansin ninyo, yung isa sa mga function, in-express lang natin siya as a fraction. So, ito siya. So, pwedeng yung kahit alin doon sa dalawang function, no? So, pwede si f yung nasa taas, kaya pwedeng si g yung nasa taas. Then, pag ganito na yung form niya, pwede na natin siyang i-apply or pwede na natin i-apply yung L'Hopital's rule. Kapag ito naman, yung limit ng dalawang function, yung sum or difference ng dalawang function na to as x approaches a is an indeterminate form of type infinity minus infinity. Then, pag-combine natin yung dalawang function. So kung ang lalabas ay indeterminate form of type 0 over 0 or infinity over infinity, apply natin yung L'Hopital's rule. O kaya naman, i-factor natin yung expression and kapag ang lumabas ay indeterminate form of type 0 times infinity, then i-apply natin yung kaninang itinuro na procedure kapag ito yung lumabas. Paano naman kapag indeterminate form of type 1 raised to infinity, 0 raised to 0, and infinity raised to 0? So if the limit of f of x raised to g of x as x approaches a is an indeterminate form of this either of the three, then susulat natin to to this one, no? So the limit of e raised to g of x ln f of x as x approaches a, which is also equal to e raised to the limit of this one, no? As x approaches a. Then we solve for this one, no? We solve for the limit of this one as x approaches a. So ito siya, which can be an indeterminate form of type 0 times infinity. So kapag ganyan, i-apply natin yung procedure kapag 0 times infinity, yung indeterminate form. And finally, ayan. So ito, equal siya dito. So e raised to the limit of g of x ln f of x as x approaches a. So nag-prepare kami ng sample problem para sa inyo. So we're going to evaluate this one. So una, identify muna natin kung anong indeterminate form, no? So since yung limit nung nasa taas as x approaches 0 is 0, tapos yung nasa baba din ay 0, then itong expression na to is an indeterminate form of type 0 over 0. So apply natin yung L'Hopital's rule. So, hanapin natin yung derivative nito nasa taas. So, we will get x times the derivative of ln of quantity x plus 1, which is this one, no? Plus ln of quantity x plus 1 times the derivative of x, which is 1. Tapos yung sa denominator naman, derivative ng cosine 2x is negative 2 sine 2x. Derivative naman ng negative secant 2x is this one, negative 2 secant 2x tangent 2x. So, tingnan natin, no? Apply natin yung x equals 0. And by doing that, ang makukuha pa natin is 0 over 0. So, dahil dyan, i-apply ulit natin yung L'Hopital's rule. Pero dito naman. So, applying L'Hopital's rule, hanapin lang natin ulit yung derivative ng numerator and denominator. So, ayan. Ang haba niyan, pero huwag kayong maguguluhan. Explain natin isa-isa. So, itong part na to, ito ay galing dito, no? So, it's quotient rule, yung low, di high, high, di low, kung matatandaan niyo. Then, plus yung derivative neto, yung ln of quantity x plus 1, which is this one. So, sa baba naman, so derivative nung sine 2x is 2 cosine 2x. Then this one, we apply the product rule. So we have secant 2x times the derivative of tangent 2x plus tangent 2x times the derivative of secant 2x. Yan. So doon siya nanggaling. So kung mapapansin niyo, no, yung denominator natin may factor na 2. Ayan, so meron siyang 2 dito. So pwede natin siyang ilabas. Bale, yung magiging constant natin sa labas is negative 1 over 4 na. So isi-simplify din natin yung numerator and denominator. So by simplifying this, we get x plus 2 all over the square of quantity x plus 1. Tapos sa denominator naman, ayan siya. So, apply na natin, no? So, we apply na natin yung x equals 0. Or ibaba muna natin rather yung x plus 1, quantity squared. So, kapag binaba natin yan, pwede na nating i-substitute si 0 dun sa mga x. So, we get here 0 plus 2, which is 2. 0 plus 1 squared is 1 squared. Cosine 2x, cosine 0 is 1. Secant cube of 0 is 1. Then secant of 0 is 1. Then tangent squared of 0 is 0. So, this is 1, 1, and 0. So, we get here 2 times 1. So, 2. Basically, itong buong to is just 2 over 2, which is equal to 1. So, multiplying negative 1/4 to 1 is 1/4. Negative 1/4 rather. So, yung limit nung kaninang expression na dapat nating gamitan ng L'Hopital's rule is negative 1/4. So, sana malinaw tayo doon. Next, ito naman yung sample problem natin. No? So, evaluate natin to. Ayan. Medyo mahaba-haba yung solution nito, pero kapit lang. So, check muna natin kung anong klase ng indeterminate form to, no? So, as x approaches 1 from the left, itong base natin approaches 1. Ito namang exponent natin approaches infinity. So, ano siya, no? Indeterminate form of type 1 raised to infinity. Thus, ayun, yung etong natin, this one, equate natin siya sa f of x. Thus, f of x equals e raised to ln f of x. And ln f of x is equal to this one. No? So we have here tangent of pi over 2x times ln of the square root of quantity 2 minus x squared. Since yung exponential function natin na e of x is continuous everywhere, then we can rewrite this one as ayan, into this one, no? Ayan. So pagpapalitin natin yung limit saka yung e. So ito na siya. So it's e raised to the limit of this one as x approaches 1 from the left. We then want to obtain this one, no? Gusto natin makuha itong nasa exponent ni e. Pero kapag in-evaluate natin to, ang makukuha natin is an indeterminate form of type 0 times infinity. So gagamitin natin ngayon yung procedure for 0 times infinity. So yung isa sa mga functions, ibababa natin, i-express natin as a fraction. So in this case, binaba natin si tangent. So ito na siya. So ito na siya. Ayan. Then kapag in-evaluate natin, no, as x approaches 1 from the left, magiging ano siya, indeterminate form na naman siya. Pero this time, 0 over 0 na siya. So dahil dyan, pwede na nating i-apply yung L'Hopital's rule. So hanapin natin yung derivative ng numerator and denominator. So yung derivative nito is this one. Yan, yung derivative naman nito is this one. So paano nagkakaroon ng 2 over pi dyan sa labas? So galing siya dito. So yung negative pi over 2 natin sa denominator. Since nasa denominator siya, magre-reverse siya ng effect. So magiging 2 over 5 na siya. Then kaya nawala yung negative kasi may negative tayo sa denominator and may negative din tayo sa numerator. So magka-cancel out lang siya. Then, ayun. Tapos, ito na yung magiging result. Ayan. This one. So, kung hindi nyo ma-figure out saan nanggaling yung 2 minus x squared, nanggaling siya dito sa taas. So, kapag minultiply natin to, magiging ano na lang siya, maka-cancel out yung square root. And dahil nasa denominator siya ng numerator, ibababa natin siya dito. So, ayan siya. So, I think we can evaluate na, no? So, we can apply yung 1, yung x equals 1 natin. So, we have here 2 minus 1, then times cosecant squared of pi over 2 times 1. So, we have here 2 over pi times 1 over 1, which is equal to 2 over pi. So, yung limit nung kanina na problem na kailangan nating evaluate is equal to 2 over pi. So, I hope malinaw sa inyo kung paano natin ginawa yung pagsosolve dun sa problem na yun. And see you in the next video.